one reference axis to steady motion, then such kind of motion is called one-dimensional motion, or it is known as straight line motion. Like train, example is the train is moving on a railway track in single direction, then it is one dimensional motion. Second is two dimensional motion, that here we need two dimension, like that it is room, and in this room we can take it x axis and this is y axis, and we are freely walking on room. So if we are walking on room, then we can say that we can go along axis y axis or we can go zigzag anyway. Here we are using this because at this point from origin we are 2 units from x axis, 1 unit from y axis. So this is 2 1 2 1. From 2 1 we have moved to 4 1 2 3 4 5, and now 1 2 3 4. So 5 4 we have moved. So we are moving with respect to x also, y also. Any kind of planar motion where we use two reference axes to tell the point. How we can tell the point? Because by x and y axis we can say where is the object and where it is going. Like there are various points. You already have referred the Cartesian plane. Have you referred the Cartesian plane, which is consisting of x and y axis? Tell Parth, have you referred it ever? Cartesian plane. Okay, now if any point is here, it is at 2 1, and now it is moving like randomly at this position. So you can say that it is now at 4 1 2 3 4 5 4 5. So here we are using two reference axes to depict the motion or study the motion or represent the motion of object. Like any ant is moving on the floor, or human is moving, man is moving on the floor, then it all kinds of planar motion. So all kind of planar motion need two dimensions, two reference axes. One reference axis means one dimension. Two reference axis means two dimension. So all kind of planar motion where we need two reference axes, that is x and y axis, to study motion. See, such motion, it is a straight line motion, and it is also known as rectilinear motion. If the motion is only in one straight line, then such motion is called rectilinear motion. It is also known as rectilinear motion. However, in this case, the path is curved because two axes. So if the path is curved, here also may be the motion in straight line, but if there is a straight line, then we will open only one of our hand to study the motion. But if we are opening one hand, if it is a straight line motion, then we will open our one hand. Wherever it is going, we will show our hand, we will put our scale on that. But if it is like this, then we need two axes. Then the motion is curvilinear. If the motion is not in a particular straight line and the path is curved, then we will say motions are of two types. One is rectilinear and other is curvilinear. So if path is curved, then we need two dimension to study it, and the motion is The motion is, पहली बात, first we have said it is a planar motion. It is planar motion. Second, we have said that the motion is 2D motion. Planar motion, this motion is curvilinear or 2D. This is 2D motion. Because it is two-dimensional motion, so we will say 2D motion. What is 3D motion? Like if and some insect is flying in our room, so that insect may take a varying height also, because it is not fixed that it will fly or hover at same level. It may go from floor, like from floor 1 2, and here it is 1 2. So from 2 to position, it may go at certain height also, because it is height also. So x axis, this is y axis, this is z axis. So the height is also a kind of dimension. In case of a flying object or a spacecraft or any aeroplane, its height is also varying. So here we need 3 dimension. That means if we write 2 4 9, that it is 2 kilometer along x-axis the plane is from us, and 4 kilometer y-axis, like you are standing on ground, then you can say the plane is now 2 kilometer from us, then 4 kilometer along y-axis. So you can locate it. First you will write x-axis, then 1 2 3 4, and then you will say now it is at a height of 9 kilometer from us. So 2 kilometer, 4 kilometer and 9 kilometer, you have also here tell that what is the height. So the motion in space where we need the third dimension, where we have to unfold our third dimension, it is we are unfolding only. One dimension unfolding, one arm we are unfolding, second arm at perpendicular we are unfolding, and if there would be any third arm, then we would have unfolded it for the third dimension. So the motion in space, the motion in space needs 3 dimension. What does it mean dimension? Means motion in space needs 3 reference axes to study it. So motion in space needs 3 reference axes to study it. 3 dimensions or 3 reference axis to study it. So this is the motion in space. Example, insect, motion of insect, fly. Here motion of man. In second case, motion of man. Yeah, man is walking on road. Here motion of train. Now here the point arises, what does it mean by reference axis? We already have seen reference point where all the motions are studied. So what does it mean by reference axis? The axis along which distance is measured is known as reference axis. Like I am here, I am at origin, because the observer is always at reference point. It is origin from where all the motions are studied. So this is reference point. And mark 10, 20, 30, 40, 50, 60. So if some object is moving like this, so it is at plus 40 distance. So along this line we are studying the motion. From observer to its left, there are the distances which are taken as negative. However, towards right side of the observer, the distances are taken as positive. So the axis along which distance is measured is called reference axis. This axis, here it is x axis. First we will take x axis. If second axis is needed, then we will take y axis. The axis along which motion is studied and the axis used to measure the distances. This axis only is used to measure the distances, how much farther is the object from us, from the reference point. And the axis used to measure distance is called reference axis. X, y and z axis are reference axis. X, y, z are reference axis. Now, these three axes are orthogonal to each other. What does it mean by orthogonal? Means these axes are perpendicular to each other. Let this is x axis. It is going infinitely on both the side. Y axis is also going infinitely on both the side. This is y axis. And this is a perpendicular axis. We cannot show it here because it is a planar paper. So, but these all three axes are perpendicular to each other. So these three all axes, you can perceive it by making a room that these are perpendicular. So only this is the way to perceive how these axes are. So this is now perpendicular. So it is x axis, y axis and this is z axis. So the three reference axes which are used to study motion are orthogonal to each other, means these are perpendicular to each other. The three reference axes used to study motion are perpendicular, mutually perpendicular to each other. Better say these are mutually perpendicular. Mutually perpendicular to each other, that is orthogonal system. Okay, now we have seen the reference point. What does it mean by reference point? The point where axes intersect each other, that is called reference point, and that is the point where observer stands. Because we unfold all the reference axis from us only along x-axis, the distance start from us only, that is origin, 10, 20, 30, because we are the main point, we are the center of attraction. So we unfold all the distances. That along x-axis, the train is at 30 units. Along y-axis, it is this much unit. Along z-axis, so at corner of the room we are standing and we are studying an insect. That along x-axis, this insect is this much distance. Along y-axis, this, and along height. You may take it like this also, that if this is y and this is z, so you can say that on the floor this ant is 20 unit from x, 30 unit to y, and if it is at certain height, then you can say 20 units of height. So 20 unit x, 20 units. So go first x axis, then go y axis, then go some height. So you can say the insect is now at the position 20 unit x, 20 unit y and 30 unit of z. So in this way, from you only you have taken all the distances. So what is the origin? The origin is the point where all three reference axes intersect. The origin, what does it mean by origin? It is only the reference point where we individually are standing. Reference point The origin is the point where all three reference axes intersect and all measurements of distances starts from origin. Observer stands at origin and all measurements starts from origin. Now, what does it mean by reference frame when we are studying motion? Then there is one more thing is needed, that is reference frame. Like we are studying two-dimension motion. So, y and y dash, reference axis along with reference point is called reference frame. This is reference frame. And all motions are studied within reference frame. Means let your pup is playing in some park, rectangular park. So rectangular park is your reference frame because all motions are taken within that frame. So it is the reference frame. Reference axis along with reference point, origin. Reference axis along with reference point is called reference frame. All motions are studied in reference frame. So all motions are studied along this reference frame. See, we have seen three things that you should add here. What are the three things? Reference point, that is origin. Next is reference axis, that is x, y, z axis. Then reference frame, origin plus x, y, z axis. So we have seen these three things: reference point, reference axis and reference frame. Now we should choose the reference point well defined for a common purpose. We should choose reference point for a common purpose. Like you cannot say some plane is crashed from a flying bird at a distance this, because flying bird is not a well defined point from where you can justify the coordinates of the plane that at this point. You can say that from Statue of Liberty at this much north, at this much south, at this much height, latitude and longitude, the plane is crashed. That is well defined. So we should choose the reference point or origin well defined so that the motion of any flying object can be clarified to all. It is well understood. In this, why it is so? In case of common notification, if you are publicly saying that this car is moving at this speed from this reference point, then common reference point is to be taken some historical building, monuments or some well known prominent place which is static in nature. That place you have to take. So it is to be chosen wisely while studying any kind of motion. Now first we will see the motion in a straight line. that is only in your subject, that is motion in straight line. Now, motion in straight line, there are two things. Like if some object is moving in curvy linear path, then what is the total length it covered? You put a thread on it and then measure the thread. Just keep on putting thread on it, lay a thread on it and just keep it tight. So when you keep it tight, the total length is the path length. Whatever path length, the total distance covered by an object on moving from initial point to final point, total length. However, that object has only covered this much distance. So this is the displacement, the minimum distance between P and Q, it is called displacement. See, an object has moved like this. So this is path length. Path length is here semicircular path. Total length of semicircular track is known as path length. However, the minimum distance from P to Q, it is known as displacement. So this is displacement. So there are two things needed to be learnt. One is path length. Path length, it is total distance covered by an object. Total distance covered. It is shown by odometer of car. Like you start your bike or scooty and you go, whatever distance it shows, while going you are going to market or somewhere, you are going in a zigzag manner, but whatever you are going, it is noted, the reading is continue on odometer. So whatever distance is shown by odometer, that is the total distance covered. Now see, odometer. Odometer. Now see, such kind of things are there on your bike. So you are seeing this is the length. One is the speedometer. This above one is the speedometer which is showing speed. However, this is the total distance covered. So whenever you are moving, it keep on increasing. It never decreases. So this is odometer. This is odometer. This is speedometer. Okay. So total distance covered by an object is called path length. For example, this total length is 15 meter. However, the shortcut length is only 10 meter. So this is displacement. Displacement is what? The distance found on line joining the initial point to final point. The displacement कैसे हो? How it is so? The displacement is the minimum distance between initial point and final point, between initial point and final point. So initial point, it is found by joining initial point to final point. It is found by joining initial point to final point. and has magnitude and direction both. And has, this is new word. What does it mean by magnitude and direction both? So both are things here. Means the displacement is PQ. It should be shown by vector because it is, such sign is needed. It is 10 meter towards north, towards right. Both the things we have to write. Towards right. However, the things which have magnitude, means a number or digit along with direction, is known as vector quantity. That is magnitude. Magnitude, it is a kind of number associated with something, and this is direction. So vector quantities are those. So displacement, it is a vector quantity. It is vector quantity. So the physical quantity, what does it mean by physical quantity? Anything which can be measured is called physical quantity, like weight, mass, density, temperature. Anything you can measure or you can perceive with your senses, then it is a physical quantity. Any physical quantity which can be measured, then that means it is associated with number, which has magnitude and direction both. Is called vector quantity. So let us see what are the other vector quantities. Any other vector quantities also there? Yes, something like some mass is there and earth is pulling downward. So this is weight. So weight is a vector quantity. Because weight is having a direction, it is downward. So example is displacement. Weight is downward. Force, because force we apply, it has a particular direction, and some newtons are forces are applied, 20 newton, 30 newton, and in some direction. So force, when we apply a force on any object, then force is a vector quantity. And the other quantity which is known as scalar quantity. Scalar quantity has no direction. Scalar quantity has no directions. What is scalar quantity? It has magnitude only. The physical quantity which has no direction. The physical quantity which has no direction is called and only magnitude, but only magnitude is called, that is called scalar quantity. So it is a scalar quantity. Example, temperature. Temperature has no direction. Like your room temperature is 25 degrees Celsius. Is it having any preferred direction? It is towards left, right, north, south. It is everywhere. So temperature. Mass, your mass is 40 kg. This is also having no direction. Mass. So in the similar manner, we have seen path length. Path length. So these are the physical quantity. Density of an object, it is also not having any direction. Heat, is not having any direction. So these are the scalar quantity which are not having any direction. There is a difference between path length and displacement. So the total distance covered by an object, total distance covered by an object is called path length. The shortest distance between initial and final point, shortest distance between initial and final point, initial and final point. Now it has magnitude only, it has magnitude only, it has magnitude and direction both, and direction both. It is a scalar quantity. It can be scaled only, it can be measured only. What does it mean by scalar? It can be scaled only, it can be measured. However, what is vector? It is directed somewhere. So it is vector quantity. If some object moves, then its path length is never zero. Its path length cannot be zero because it has moved. However, if some object moves and come back to initial point, returns back to initial point, then its displacement is zero because the initial and final points are coinciding. So now there is no displacement. So if it is moving, then its value is non-zero. If it is moving but comes back to initial point, see here in this case the path length is 10 meter but displacement is 0. This is the 10 meter total distance covered, but the displacement is the distance between initial and final point, which is 0. If you are going to market, after purchasing something, you come back to your home, then your displacement is 0, though your path length is never 0. If object moves and comes back to initial point, then its displacement is 0. See, the path length is always greater than or equal to the magnitude of displacement. See, like here, path length is always greater than. Here you can say this is 15 meter, this is 10 meter. 10 meter is displacement and path length is 15 meter. So path length is greater than. And in certain cases, if object is moving in a straight line, then it is equal also. In this case, path length and displacement are equal. So path length is either equal to or greater than the displacement. This is path length. If object moves in curvilinear path, then path length is always greater. If it is a straight line path and never returns, then both are equal. This is displacement. So path length is equal to or either equal to or greater than magnitude of displacement. Magnitude, you always write magnitude of displacement because displacement has two perspective. One is magnitude and other is direction. So you can say that path is better than the path is better means path is going for academics only, but Nikhil is having dancing skills and academics. So you can say path is better than academic Nikhil. You cannot say than Nikhil because path is not knowing how to dance. So in this case, path is a scalar quantity. However, Nikhil has dancing skill and academic skill. So here we are comparing. So we will say like that path length, because path length is having only a particular magnitude scales. However, the displacement is having both the scales. So here we are specifying, you should write greater than magnitude of displacement, because your comparison is limited only for magnitude only. Path length is not having any direction, so how can we compare the direction of them? Only we are about magnitude, so specify for magnitude. Second, here the magnitude of displacement is less than or equal to path length. Magnitude of displacement, because displacement is having two scales. Magnitude of displacement is equal to or less than path length. See, here we have seen that the differences between them. Now, if David moves in a square path and it has moved 10 meter here from A to B, then path, can you say what is path length here? If it has moved from A to B, then what is the path length? Pardon? Okay, and what is the displacement? It is the square root of 200. It is very correct you have said, because this is the displacement. This is the shortest distance between initial point and final point, and by Pythagoras theorem you can find it out that it is ACB, it has moved. So ACB's path length is the total distance covered. Path length, it is 20 meter, and displacement, it is AB, and it is also directed like this. So what is AB square? It is AC square plus BC square. This is 10 square plus 10 square. Now, what does it mean by AB square? It is 100 plus 100. And now take root 100 plus 100. So it is root 200. Root 200 means it is root 2 into 10 into 10. As 10 is in pair, so as 10 is in pair, so what you can write? It can be 10 can be taken out from square root. So AB is equals to this much, and also you have to write from A to B, because you need to specify the direction. So from A to B, this is the displacement. Root 2, it is 1.4. So if we find it out, would you able to find out root of something? Root 2 is 1.4. So it is 14 meters the displacement. Otherwise you can measure it. It is 14 meter. However, it is 20 meter. So we have seen path length is greater, but displacement is lesser. See. Now, just There are some papers you can take a screenshot of them also if you need it, so that you can take the screenshots of these. Okay. Now just better to have a snap so that I can put the next paper. Have you taken it? Okay. Now next, take a screenshot of this also. So, okay, now there is, I will also forward the PDFs of these pages so that it will be good for you. Now there is one question for you. Now, if a farmer in his square field, moves from one corner at 1 meter per second. 1 meter per second. This is a square field and he is moving from 1 meter per second. Having a side 10 meter. Having a side 10 meter. Then after 140 second, what will be his path length? He is moving from A and keep on moving along the periphery. He keep on moving 1 meter per second. So after 140 second, what will be his path length and displacement? So this is the question, that a farmer moves along a path. Second question. And in this way, after 140 seconds, what will be his displacement and position? So this is the question for the next class. So we will discuss it. Otherwise, you may try it also. Thank you all. Any kind of botheration or something which we can improve in the next class? Okay. Is it getting recorded in your phone? Or shall I send it on a link for YouTube of this video? Is it getting recorded? हेलो मेरे स्वामी करुणा सनी। मेरे अल्लाह. Hmm.